Hello? Hey, thanks. Yeah, so looks like we have lots of shining topics today, and we start getting to the zone that we start to talk about what SONiC hasn't been do fully 100% shiny and great yet. So this is probably yet another topic that I'm going to cover some areas that SONiC could do better, and we need help from the community. We call for help and a call for actions. So I think most of here, this is my agenda today, the topics I'm going to cover. So some of them might be, I'll go through really fast, like a SAI brief. Everyone knows about what SAI is about, hopefully. And why do we need a SAI qualification framework? We do have one right now, and why do we need it? And what are the generations of the SAI qualification framework that we have so far? And how does it work? And then it naturally leads into what we want to see it do better, and what are the potentials, right, and call for actions. Yeah, this one, everyone knows about it, right? So hopefully, SONiC is basically a network OS with features abstractions into Dockers. And particularly, upper layer features will go through SWSS, and FR routing is one of the great examples that we just have a coverage, and go through SWSS, which is a centralized place, and go to the syncd, which connecting the SWS states and the ASIC states. And then going further into the box at the bottom, we go through the SAI API, and then vendor SAI implementations, and go through the SDKs, whatever underneath that needs to get all the plumbings done, and eventually configuration get into the ASIC, and good things start to happen. So why do we need the SAI qualification framework? That seems to be a silly question, right? So what do we have today? Today we do have a quite good coverage of PR tests that covers most of the control plane behaviors, which is open source in SONiC management repo. And every time you raise a PR in SONiC management repo or SONiC build image repo, it will get executed. And you will see the new image get built and test cases get executed to make sure that the change that you're trying to make at least is good for the control plane. And then because of those PR tests are run on the virtual platforms, we're not able to fully cover the data plane and the ASIC behavior. So there are fleet of the nightly test bed that I think probably every cloud vendors, including Microsoft, has in their labs and continuous running nightly tests to validate the data plane, control plane, management plane, and also platform behaviors. And all those things are open source. And I'm sure that all the SAI vendors that works on SONiC SAI have their own unit test framework. They're mostly proprietary. And they must have some integration tests. Some are private and some are public open source, right? So some of the vendors, hopefully all, are using SONiC management framework to test SONiC behaviors on top of SAI. But that is some improvement we start to see recently. Before that, we do have some gaps that not all SONiC behaviors was covered before the SAI release was cut. So some common areas that we see misses are, for instance, upgrade path especially when upgrading across branches from an old release to a newer release, right? So we do have a great success in collaboration with the community to deliver the first generation of a warm reboot. But we did hit a sort of a hiccup when we're trying to upgrade from the initial branch to the newer branches, right? So because there's just another set of problems that we need to deal with, another set of complications we need to deal with, and not all SAI vendors will test all the configuration combinations that are going from branch A to branch B. So that's just reality, right? So, and then there are some risk conditions. and hardware failure triggered scenarios that may or may not be covered in the daily or unit tests or your daily tests. And the pain points that everyone suffers, right? So the SAI release qualification. So basically, qualification related to SAI start later in the game, right? So usually when we cut the branch, at around that time, we got a SAI drop from all the vendors. And we start to run SONiC on top of this release and SAI release. And then we start to discover all the issues that are related to SONiC behaviors. And that is a little bit late to the game. Fortunately, what we also see at the same time that from branch over branch is that all the vendors are learning from the failures or hard issues that we discovered in the past and try very hard to improve their internal test infrastructure and test cases. And we definitely see the SAI quality getting better and better over release over release. But some of the pain points still there, right? So, what we have today already in the public open source is a SAI PTF qualification framework that was initially contributed by Intel. And yeah, so the first version, there are a few parts, right? So we have some PTF servers to run, and the DOT, the communication between PTF server and the DOT, we have a unit test to control the behaviors of the SAI, and we have Python helpers to run those unit test cases. And then we talk to the client, the helper part talk to the RPC server on the DOT side, and drive the SAI behavior, SAI API calls and attribute settings, and then we validate the outcome of those SAI API calls and attribute settings and or removes and etc. And that is basic structure of the SAI PTF qualification framework, how it works together. And underneath the scene, right, how do we generate those metadata for SAI qualification framework to run? We do use Doxygen to generate XML files from, we take the Doxygen helper information from the SAI headers and generate some of the XML files and eventually take it one step further to generate some Perl data for the SAI objects. So basically, what we did here is that we passed all the SAI headers to figure out what are the SAI APIs available in the new SAI, basically the feature set, and what attributes are available to those new APIs, and then we generate the metadata. And the first generate, so from there we have to further generating a RPC server code and client code. At the first iteration, what happens is that we generate this package called a SAI Swift, right? So with the Perl data that we generated from the last step, we take it further and we use a template to generate a skeleton code. But then developer has to go in and add some code, actually implement those APIs between the client and servers so that the communication could happen. So Microsoft came in and pushed this to the next level, make some improvement on top of that. And we are, so it's not that basically we could also, we could run in the PTF fashion in the first iteration already. Microsoft added in some more packaging and make it more streamlined so that you could deploy in test bed. And once the test bed is deployed, the test bed is ready to run those SAI qualification tests. And also there's a key improvement from Microsoft is that we added the auto-generation SAI RPC client and server code. So developer no longer needs to go take a skeleton code and type in all those communication code in those APIs. All those code are auto-generated with the second iteration. And we also added a whole bunch of test deployment and image upgrading. We integrated the whole pipeline, the whole testing procedure into our pipeline. With Agile pipeline, we could run this set of SAI qualification smoothly and with one click, basically. So so a very primitive way of running the test is go to the PTF Docker and run PTF test, issue PTF command directly. And of course, SONiC's test infrastructure has enough wrapping so that we could also call those tests from a netlist test fashion, PyTest fashion, right? So basically, you can run it through a netlist test. And on top of that, adding more packaging, then we could run through the Agile pipeline and collect the test results and upload to some database so that we could further analyze, and you could see those good pie chart and stuff, right? So the blue one is showing number of test cases for each function area, feature area. Right, so the bottom green and red ones are passing and failure rates. And on the right-hand side, it's a breakdown of coverage, number of functions is different feature area, again, similar to the pie chart. So what do we have today? What it covered today is that we believe, from our data analysis, that we have 85% of the SAI API covered by SAI test framework, and 70% of attributes covered in this test. So that immediately, right, everyone sees that there's opportunity to improvement. Well, we're not 100% covering all the SAI APIs and SAI attributes yet. So there's a way to go. And I kind of touched this point a little bit earlier that we have some risk conditions, right? So some of the operations, when walking into this maze of chains of the operations that are going down from SONiC to SAI to ASIC, we might have different ordering because of the timing, risk condition. So the question is that if we issue operation 12, 16, and then 18, does it equal to 12, 18, and 16? Yeah, that question probably triggers some people's recent memory. But anyways, we do have some issues like this happening, right? So how do we cover those scenarios? How do we discover those scenarios, right? So some of the possibilities that this is an open suggestion or question, right? So like, I don't know how many people here are familiar with the TLA plus framework. This is basically a framework doing kind of exhaustive testing. So basically, you give it a diagram of things could happen in such and such order, and some orders are loose, some orders are more strict, right? So, and then TLA plus will come in and do a whole bunch of exploratory tests, basically try to exhaust all the passes between this in your graph that you're providing. So how is there a possibility that we could build some more sophisticated test cases or frameworks with TLA plus and such to actually exhaust more code passes or combinations of different SAI operations? Right, so the risk conditions, yeah, timing issues, risk conditions. How do we deal with them? How do we figure out them, right? So, so exactly for call for actions, because we definitely want to have a continuous stream of high quality SONiC image and feature branch coming every 6 months to everyone, right? So then how can we improve the test efficiency, of this SAI test framework? And how can we use this framework to actually prevent regression? Some of the gap I see here is that are the RCA, the certain RCA issue and confirmation, the issue fix and validate the fix in the end, right? So I see some gaps here. Today, one of the gaps is that how do we get the ASIC to a certain initial state before we try our subsequent SAI operations. Right? There are some thoughts and some of them has been captured in this framework today, right? So one of the way that already available is to have a SONiC run into a certain state, and by that time we capture the config DB, and then we save that config DB, and in the SAI qualification framework, we load that config DB as our initial state, and then we started our exploratory from there, right? So with that infrastructure, then I think there should be sufficient support for quickly validating if we're suspecting one of the sequence is the cause of certain issues. Then we could quickly bring the system up to a certain state, and with a quick test case instruction, with a sequence of SAI API calls that we can validate our theory or disprove our theory. So those are opportunities that is there for the community to actually take the benefit of this PTF SAI test framework. And of course, we want to get help from the community to push our coverage to 100%, right? So a disclaimer here, right? So test only tests what we know we should test until we have that exhaustive test framework. But anyways, if we could continue contributing test cases and to this framework, then there's a great opportunity for all the vendors to qualify their SAI and make it working, if not 100%, 99 or 5 nines to SONiC, right? So before they even release to the community. So we capture lesson we learned in the past and help us so we don't fall into the same pit in the future. So there's lots of opportunities there for us to help us to shift to the left. I'll leave that road wide open for the community to participate. And I think that's all I have today. Thank you.